Hi, my name is Divin Emmanuel. Today I'll be showing you how to remove, test and refit an ABS wheel speed sensor, and also how to carry out an MOT vehicle inspection. So I started off by putting the OBD sensor into the OBD port. Since the battery was flat, I connected the jump start battery pack to supply power and turn on the ignition. I then turned on the ignition, and as suspected, the amber ABS warning light illuminated, indicating that there is a potential fault in the anti-lock braking system. At this point, the diagnostic tablet became an essential tool. It was crucial to ensure that the tablet was scanning the correct vehicle. And as shown, the vehicle information was accurate, which allowed me to proceed with the rest of the practical. Since the vehicle is a manual transmission, those are the settings I selected before carrying out the scan. A system scan is crucial as it allows me to identify specific faults within the system and determine where the faults are located. Fault codes are highly efficient because they quickly highlight the source of the problem, preventing me from having to do a time-consuming manual inspection on individual components. As observed, both front wheel sensors on the driver's side and passenger side are showing open circuit faults. I will look to assess and rectify these issues by the end of the practical. Both rear sensors are functioning correctly. However, I will still perform standard checks to ensure they are operating efficiently. Reading data when carrying out a diagnostic check is crucial, as it offers more accurate insights and helps verify faults with more precision. Here I am spinning the wheel and repeating the same procedure for the others to monitor the live data readings. Live data is essential during a diagnostic check because it provides real-time information on how the vehicle's systems are functioning. This will allow me to observe the behaviors of the sensors while the vehicle is in operation. The live data shows that both rear wheels are functioning correctly. We can see that through the readings. However, the front wheels failed to show any activity, suggesting a potential issue. This gave me the license to carry out further checks. I then retrieved an impact gun and used a 19mm socket as shown in this image, which I used to remove the wheel bolts. This procedure was done to gain access to the sensors and inspect them for any potential faults. Once the tire was removed, I then placed it in a safe location to prevent it from becoming an obstruction or a potential hazard. I repeated this procedure on the passenger side as well. Once the wheel was removed, the fault became immediately apparent. The wheel sensor was disconnected from the ECU, and this explained why there were no readings on live data from the right wheel sensor. As there were no visible signs of corrosion or physical damage, I reconnected the sensor, leaving it in a place for diagnostics at a later stage. This is where the ABS sensor is located. I used a Torx socket to remove an already loose screw. In most cases, a ratchet would be required for removal. However, in this instance, it was not necessary. Once the screw holding it in place was removed, I was able to take out the sensor and proceed with the continuity test. I then performed a visual inspection and it was immediately clear that the wheel speed sensor was in no condition to function. A noticeable hole in the sensor would have prevented any continuity from passing through the component. I decided to carry out a continuity test, and as expected, no continuity was detected through the component, indicating that it required immediate replacement. I carried out the same test on the driver's side sensor, which provided a positive reading, indicating that it was healthy and functioning correctly. I then refitted the sensor in preparation for a reassessment of the wheel speed sensor. Both wheels were then refitted in preparation for final assessments of the wheel speed sensors. Although I failed to record it, I used a torque wrench and tightened to 135 Newton meters according to manufacturer specifications. All bolts were torqued accordingly. I did this using the star pattern to ensure even force. A floor mat was used as knee support during the wheel refitting process to improve comfort, which would naturally increase the job efficiency. And as the live data shows us, the right wheel speed sensor fault has successfully been rectified, and the sensor is now operating within its expected capacity. However, upon inspection, the left wheel speed sensor was found to be unsuitable for reuse. A replacement sensor has been ordered and will be refitted immediately upon its arrival to complete the repair. In this practical, I'll be carrying out an MOT vehicle inspection. I'll record my results on the job card. To begin the inspection, I started by checking the seat belts to ensure they were intact and fully functional, as they are one of the most crucial safety features in the vehicle. I checked the locking mechanism, which is designed to detect any sudden movement and prevent car passengers from being thrown forwards in the event of a collision or heavy braking. I also tested the buckle to ensure it would securely hold the belt in place. I applied a realistic amount of force. I also inspected the seats to ensure that all the adjusters were functioning correctly, and that the headrests were also secure and stable. I carried out these procedures on all the seats to ensure that it was safe. Next, I examined the door panels to ensure they were properly secured and weren't loose. I also listened out for any abnormal noises or clicks.
Yeah, we'll do it on the other side as well. Sound. Back.
I then pressed on the brake pedal to ensure it was not spongy. A spongy brake could mean that there has been a brake fluid leak. Next, I inspected the steering system to ensure it operated smoothly and without any resistance. I also checked if the steering wheel adjusters were functioning properly, as they're made for repositioning and aiding the driver's comfort. Here I was listening for any grinding noises. And as you can see, the steering operation is working just fine. I then tested the horn to ensure that it was functioning correctly. I revved the car to get a reading on the dash, which also worked. It was time to do the exterior vehicle checks, so I began by inspecting the front lights. As shown, the daytime light on the passenger side was not illuminating, indicating the bulb was faulty and needed replacing. However, the dipped headlights, full beam headlights, and indicators were all functioning properly. I carried out the same procedures for the rear of the car, as it's just as crucial as the front. The rear plays an important part in signalling your intentions to the drivers behind you, helping ensure safety on the roads. I then assessed the front and rear wiper motors, and they were both functioning accordingly. There were no grinding noises and the operation was smooth. The next thing I did was open the bonnet, which as you can see was in good condition. First I checked the coolant tank. Since the engine was still warm, I decided not to open the tank as it still would have been pressurized. However, from visual inspection, the coolant was in correct range. Next, I used a dipstick to check oil levels, which was satisfactory. I also removed the oil pressure cap to inspect for any milky residue, which would indicate head gasket failure. And here's an example. It's not something that you'd want to see on your oil cap. Thankfully, there was none. I then assessed the mirrors and the mirror adjuster to ensure that they were operating accordingly. I then carried out a suspension check by rocking the vehicle. I was looking for any excessive bouncing after stopping, but there were no signs of it. I then began to inspect the vehicle's body and noticed the registration plate was bent. Shortly after, I discovered 2 chips on the bumper. However, when applying reasonable force, I confirmed that both front and rear bumpers were stable and securely attached. I then inspected the petrol cap to ensure it was intact and still capable of providing an efficient seal. It was now time to lift the vehicle, and here I am locating the vehicle's jacking point. Once I located the vehicle's jacking point, I made sure my working area was clear and proceeded to jack the vehicle. I then spun the wheel and looked for any wear and tear. However, the tyre was in good condition. The minimum tread depth on every car is 1.6 millimeters, and as you can see, there's a line indicating that. I then rocked the wheels to look for any sort of play in the track rod ends or the ball joints. As you can see, there was no play, so it was in good condition. I then carried out further checks and further inspections, and as you can see, the CV joint rubber is intact. There's no sorts of cracking. As you can see, the ball joints are stable. I then proceeded to carry out the same procedures on the passenger side of the vehicle. I then proceeded to check the vehicle's fuel tank. As expected, there was a slight bit of corrosion, however, there were no oil leaks. I assessed the condition of the brake discs for any corrosion and any signs of uneven surface. From both visual and physical assessment, they appeared to be in good condition. I then opened and closed all the doors to ensure that they were functioning without any sort of obstruction. There were no noises of disturbance coming from the car doors either, insinuating that they were in good condition. I then conducted a road test to ensure that all the components I inspected were functioning correctly. This included assessing the performance of the brakes, steering and suspension systems in real driving conditions. And here I've attached my job card. Thank you for watching my video.